You should be looking at our Canvas site. Is that agreed? Right. So what I've done on our Canvas site is, if I can find the damn thing, it better be here. It is. I have put 2 PDFs with what we're going to be doing today and into tomorrow. So you don't need to write anything. All you need to do is just kind of listen along, because it's going to be one of those describing different types of sampling methods and what's bad about them and how you can fix them. And so rather than you having to frantically write down 8 different sampling methods and what they mean, you can just print out this PDF in your own time and it's there, right? So hopefully that'll make your life a little bit smoother, and it allows me to add things as well. So we're going to look at a summary of sampling methods. So we talked last time about how you can get a sample, right? A small representative group of the population, and then you go and ask them questions like, do you smoke cigarettes or whatever, right? And you collect it on that. And if you've got a good sample, you can then interpret that, right? You can then say, well, if 20% of my sample smoke cigarettes, it's a pretty good guess at about, and you always use it qualified, about 20% would probably also in the population do it. So here's an example of a sample. It's called a stratified random sample. And what you do here is you collect, you take your sample, right, and it's collected by first dividing the population into units called strata. I'd call them subgroups. So you imagine your population is all adult voters in America, right? That's my population of interest, because I want to know who you're going to vote for in the next election, right? Let's say that. Or let's suppose, make it easier, I want to know if you're going to vote in the next election, not who you're voting on, just are you going to do it? And so you could simply just take a simple random sample of 2,000 Americans, and that is perfectly fine. But in a stratified random sample, what you would do in this story is you'd say, okay, I want to make this a fair representation of everybody. So shouldn't I make sure that I get at least some people from every state in America, right? Because couldn't people in Alaska vote less often or more often than people in Arkansas, right? So as long as my sample's got them. So I would take my sample and I'd say, okay, I'm going to break it into 50 states. Maybe my second strat, it's probably a good idea not to do more than a couple, is males and females. And I want to make sure that I've got roughly 50 of each, right? 50% males and 50% females, because maybe women vote more than men do, or maybe men vote more than women. So I want to make sure that, you know, I've got a good combination of both those. And then you just break your population. So you might say 50 Alaskan males, 50 Alaskan females, but 200 male Californians and 200 female Californians. Why would I be asking a lot more Californians than Alaskans?
Population density?
Yeah, there are a lot more Californians in America, right? So if I wanted a fair representation, shouldn't I also be factoring in relative sizes of each of these groups? So I'm sure I could figure it out. It's probably a bigger proportion than that, but you know, let's say there's 10 times as many Californians as there are Alaskans, then shouldn't I have my strata have 10 times more Californians get asked than Alaskans? And that's how you keep it fair. Right. Now, the second one is called a cluster sample. Let's see if I can make this a bit bigger. There we go. In a thing called a cluster sample, here is an example of one. What you do is you take your population again and you break them into subgroups. But rather than sampling within every cluster, a random sample of clusters are selected. Okay, let me show you how that works. Suppose you were interested in people's opinion of abortion, but the population that you're interested in asking that question isn't everybody in America. It's only people who work in hospitals. Right, so you're interested in only hospitals. That's hospital workers, janitors, brain surgeons, right? If you work in a hospital, I want to know what your opinion of abortion is. So what you could do there is a simple random sample, but can you see how difficult it would be just to collect the information to allow you to do a random sample of those people? Wouldn't it be much easier just to get a list of, I'll make this up, the 5,000 hospitals that are in America? Each one of those hospitals is essentially a cluster. And then within those 5,000 hospitals in America, you randomly pick just 100 of them. And then what you do is you ask every single person in each of those hospitals. So do you see how that cluster sample works? Your clusters in this case are hospitals, right? You get 5,000 hospitals in America. Right? You pick randomly from that group, and then you ask everybody. Right? An interesting way of getting around a problem. Simple random samples are typically the best random samples in the world to use, but they have major problem. Sometimes they're very difficult to do. So these other versions that I'm telling you are the workarounds. Can you see that the cluster sample wouldn't be that hard to do? Right? I'm sure somewhere there's a list of every hospital in America, right? And couldn't you pick 100 of them at random and then off you go? Right. Next thing. A systematic sample. There's their formal definition. Let me give you an example of what that would look like. Suppose I wanted to get a sample of 200 people from Olympic College. I wanted a random sample. A systematic sample could simply just be get a list of every single student at Olympic College and have them numbered 1, 2, 3 down to 5,000, say, right? Everybody. And just go, I'll pick student number 1, student number 101, student 201, student 301. So you see how I've got a kind of systematic way of choosing who from the entire group I pick. That would be an example of that. A systematic sample could be, I'll pick one person whose last name starts with an A, and then the first person whose last name starts with a B, and then work way through the list that way. I wouldn't get a very big population, a very big sample that way, but I could do it. Suppose I'm interested in voting. Are you going to vote? Couldn't I just pick a street and pick whoever lived in house number 1, and then go to the next street, whoever lived in house number 1, then go to the next avenue, whatever it's called, who lives in house number 1, and only pick the people who live in house number 1, right? The first house in any street, boulevard, whatever else you call it. You see, that would be systematic. In other words, isn't there a structure to how I pick the people? And it's a pretty consistent structure. It's maybe not the best sample in the world, but would you agree it would get you a sample, right? It would get you something about people who live in Bremerton. Everybody here has probably had this done to them, but not in a nice way. Have you ever randomly got calls from people you never wanted or knew, and they ask you things? That's random digit dialing. They use it to sell you stuff. Don't you get, oh, would you like to reinsure your house? Or we can give you a better deal on your car insurance. You ever had those phone calls? I'm lucky, my phone has a thing, scam probably, or it says, and I just ignore them, right? But that's an example of a random digit dialing. What they do is, it's done by some gizmo. I think it's illegal now in many places, isn't it? To robot dial people. You know, this is your governor, I'd like your support in electing me next year, you know, that kind of thing. They're not allowed to do it in some states. You're interested in, let's stick to the, are you going to vote again? They get a computer and it randomly picks telephone numbers. And then it calls them, and there's a person who sits there, and it phones, and it comes up, and if the phone gets picked up, they say, "Hi, my name is James. I'm doing a survey about, are you going to vote?" And they get their answer. Can you see that you can get a very quick sample of people by just phoning them? It's getting harder to do accurately, because haven't a lot of people got blocks on their phones, so you never get to phone them, and so the people you eventually get through to might not be a fair representation. And there's some clues on that. Has anybody had this kind of sampling? Internet panel sampling. Because telephone surveys are dying, because people don't answer their phone, they're getting used to it, they're not bothering, plus they block the numbers. This new technique, internet panel sampling, what they do here is that, well, one version of it is you actually get hired to take part in the poll. So you might get, they can communicate it with various ways, but they might find your address and they send you a letter and they say, would you like to take part in this television poll? And what you're going to do for us is record the television programs that you watch in the next month, and we will give you money for doing that. I've actually got one where I was given $5 to do an educational survey. So I filled in a big form. I did it online, right? Filled it in, and they gave me $5 when it's completed. And they did. And they didn't even send me a check. Do you know, they sent me $5 cash. So you get recruited, and you do what they ask you, right? You answer the questions, whatever it might be, and very often there's a payment involved. And if it's not a payment, they say, well, you'll be randomly entered for a draw for $1,000. So one person will get money, the rest of you don't. Has anybody had that done to them?
I haven't had that done to me, but I have seen it on like Facebook where people are like, I made this much money taking these surveys. And I was like, that seems sketchy though.
It does seem sketchy, and it could well be sketchy, but within that sketchy, there could also be some true situations where that happens, right? Don't do one of those that says, yeah, we'll send you $100, give me your bank account details. Those are sketchy, right? But if they say, we will post you, you know, whatever it is, we'll send you an Amazon card for $10, right? Whatever way they're doing it. Those are, you can't lose out of that, right? I guess you could lose some of your time because they might not pay you, right? But you can't lose out of it. So never tell anybody your bank account details. I mean, that's just not a good idea, right? These examples of sampling that I've been talking about are all to do with the fact that we can't always do simple random sampling. If simple random sampling was easy to do, we probably wouldn't use any of those other techniques I just mentioned. But you can see that some of them have, they're convenient, right? They allow us to at least get information. And if you do it well, you tend to get pretty good information as well. The last one is multi-stage sampling. Basically, if you figure out some very convoluted way of mixing and matching at least two of the techniques I mentioned earlier together, then that's going to be called multi-stage sampling, right? So maybe you robo-dial 2 million people and 100,000 of them reply, but you only randomly select 100 of those and pay them money to answer the thing online, right? You see that would be a kind of combination of the internet poll one and the random, the robot calling one. Are we good? I know today's a lot of listening, I apologize for that. But hopefully you're getting some good stuff. Here is a very brief summary of what we talked about. And that is, as far as I'm concerned, the end of that particular I'm not sure what to call it now, that particular piece of work, right? So let's leave that and eventually go back into here. And I know I've got it set up somewhere, just have to find the right one. No, okay. While I am setting up the homework thing, why don't clams, C-L-A-M-S, why don't clams buy you presents?
Because they're shellfish?
Yes, because they're shellfish. Where did you hear that joke? Can't
It was
remember.
a lucky guess.
Oh, it was okay. You just figured that out. Yes, it is. Okay, I'm almost there. You probably, I don't know what you can say right now. I'm taking out the answers because they distract the heck out of me. I don't know. Put it in. Put it in. It's just as quick. Saves me having to read the questions. That way we can look at the answer and why it is the answer. Okay, are you looking at sampling introduction, chapter 5? Okay. So what they do here is they give you a story or a question, and then it's pick one or more of the dots that go by. Let's say this. In each case, briefly discuss whether you think the available sample data can be used to make an inference about the larger population. So the heights of women in a psychology class will be used to estimate the average height of all women at a college. Right. So you want to find the average height of women at Olympic College. And so you get a psychology class and you measure the average height of those women. And they had said, yes, the sample data could be used. And they're saying it because, well, let's think. Would you think that people who take psychology, women in particular who take psychology, do you think they're any taller or shorter than all the other women at college? And I would think, well, I can't see a reason for why that would be the case. So let's give you a bad sample. You want to know the average height of women at Olympic College. So you use the heights of our basketball players. Would you agree that wouldn't be a very good sample? Right? For example, right? So if you think the people you're asking are probably kind of like the rest of the population, go for it. If you think the people you're asking, that's your sample, are in some way maybe not the same as the rest of the class or the population, then you probably shouldn't use that. Parents of children attending a daycare facility are asked whether the state government should increase funding to daycare. So you only ask people who have children at daycare whether or not the government should increase the funding for daycare. Why would that be a bad sample? Because it is.
Because they're going to be in favor of the daycare system where people that either don't have children, don't use daycare, won't be.
Yes. Would you agree that there's a fair chance that that group of people might be more in favor than, you know, a 70-year-old person who says, I don't want to pay extra money for daycare. I don't even have kids, right?
Very biased.
Yeah, okay, very biased in some cases. Okay. Question 3, a political scientist asked 300 voters randomly selected from a list of all the registered voters. Yeah, that's a good one, would you agree? Right. If you want to find out who's going to an election, they almost always go to the voters list, right? Which I believe is available publicly, which basically just has a list of people who are allowed to vote. And you could use them to ask whatever it is you're interested in. They sometimes use that not just for voting, because it's a good, convenient way to get information about anybody who lives in Bremerton. Would you agree most people who live in Bremerton that are adults, most of them are probably on the voters list? Now, not 100%, won't you miss people who just didn't register to vote? You won't have me because I'm not allowed to vote. No, I'm not a felon. I'm a foreigner. It's the same thing. You're still not allowed to vote. In this case, the sample are the 300 people you registered. I think I'm going to put the answers off now because I thought they would cause me problems, but they're kind of distracting me, so I don't want to get too distracted. Let's just move down randomly to here. Okay, this is a good question because it's actually one of the few things that I've seen where we can get numbers. In a class of 18 students, and they give you some fictitious names, etc., a simple random sample of 2 people is going to be selected. Use the definition of a simple random sample to compare the chances that John and Marie will be selected with the chance that Marie and Bill will be, let's say that, chance that John and Marie will be the group selected with the chance that Marie and Bill will be selected. Okay, I don't need a calculation. Isn't it going to be the same chance that any 2 people get picked compared to any other 2? So there isn't even a number. I should have read the question. Now, hear about this one. Briefly explain between a sample survey and a census. Now, there are a whole load of sentences there, and you could read that, but in your own words, what's the difference between a census and a sample?
A census intends to count the entire population, where a sample is only a sample.
Yeah, and then go through that list and figure out which one of them is the same thing that Rob just said. That's kind of how I would do these questions. I would figure out what my own answer is, then I would read theirs and see which one means the same as my answer. Question 9. A friend has recommended the work of a musician who has recorded 4 albums, and each contains 10 songs. You decide to visit a music store and listen to a simple random sample of 3 of his songs. Suppose that you randomly chose 3 of the albums and then randomly chose 1 song from each. Okay. Would this be considered a simple random sample or not? Remember all those different samples we did today? It's not a simple random sample, is it? If it was a simple random sample, couldn't he actually, in some situations, pick 3 songs from the same album? Or 2 songs from one and 1 from the other? So it's not a simple random sample. So one of those answers corresponds to that. Oh, let me change the question. Let's do some other rock band. They have made 12 albums in their entire musical career, right? 12 in my story. You randomly pick one of those albums and then you listen to all the songs in that album. What kind of sample is that?
Would it be a cluster?
It would be a cluster, yes. If I decided to take all 12 albums and randomly pick 2 songs from each album, that would be a stratified sample. If I decided to listen to the first song in each of his 12 albums, wouldn't that become a systematic sample? Right, first song in his first album, first song in his second album, right all the way through. So do you see that these are different ways of sampling the songs? I mean, wouldn't a census be, I listened to every single one of their songs? I guess at the end of that, the answer would be, I like this guy, or no, I don't, right? So, you know, that's how you would get through that type of thing. Okay, now, that's a good time for me to pause And now we're going to go back to, if I can find my page, here we go. We're going to go back to some more notes that I've done, because what I've got is a list of potential bias, things that can make your data not representative, and therefore you should be really careful about any conclusions that you come to. It should be ready now. Right. So we're going to look at bias in collecting data. So this stops us having to, do our thing. Right. This here is a sampling frame. And what can go wrong is you choose the wrong sampling frame. Let's tell you what that means. You've got a population of people that you're interested in. Let's say that you're interested in smoking habits of high school students, right? Whether they smoke or not. And you decide to do a sample by only using students from high schools. The sampling frame that I'm using there then is students from high school. Now the sampling frame is people that you're going to pick your sample from. Shouldn't that sampling frame be the same as the population? Who have I missed out when I want high school students that smoke? If I only go to high schools and get the people that I talk to from there.
Homeschool students.
I didn't catch that, Robert.
Homeschool students.
Homeschool students. You see, my sampling frame caused a problem there. If you can't ask them, you'll never know what their answer is, right? Suppose I give you an example. Suppose I'm interested in, are you going to vote in the next election? And I use as my sampling frame, people who I phone. Who have I missed?
People who don't own a phone?
Yeah. Now you might think that's highly rare, which I'm sure it is, but don't some people just don't like phones? This surprises me. Do you know there's some people who don't have televisions? I'm not mentioning names because that's not my job to tell you people. I know a professor who doesn't have a television, doesn't watch it, don't care, don't want to see it, too much garbage on it, doesn't like it. Could you agree then there's probably some people who just don't like phones? Now, it could be, at one extreme, couldn't it be they're just really poor, right? They can't afford the phone, they didn't pay the bill the last time and they get cut off. Now they're on a list of don't sell this guy a phone or don't use this guy because he doesn't pay his bills. You know, one of those. You miss those. See, sampling frame is the people that you ask in your sample. A good sampling frame should be the same as the population. If it's missing people, isn't there a possibility of not getting a fair representation of everyone because of that? Like, I think the homeschool would be a good example. I'll make up an excuse here for why I think that would be good. I bet you, and this is just a gut feeling, that homeschool students don't smoke as much as high school students. Because homeschool students have their mum and dad teaching them. What's the chances you're going to get away with smoking in that kind of household? Agreed? Very little. High school students, their parents aren't there, you know, lunch break, who knows what they got to, right? Isn't there more opportunity for them to become smokers? So can you see the data would get distorted because of that, right? Sometimes it doesn't matter. Okay, let's do the high school and smoking one. For some weird reason, you're going to ask everybody except people who are blonde. For some reason, the way your sampling frame worked, blonde people never get added to your list. Do you think blonde people smoke more or less than everybody else? Probably not. Can you see that in that case, it didn't cause any damage, right? So just because you don't get to talk to everybody because your sampling frame's not perfect, It doesn't mean it's the end of the line. Couldn't it just mean, it probably won't matter, you know, if I miss this? Okay. Not reaching the individuals that you selected. So you've got a sample, right? And you're trying to contact them, and doesn't work. Pretty much it. We've talked about these, non-response, volunteer response, and non-participation, but just for completeness sake, right? Non-response is, you know, you got the person on your list. Are you going to vote in the next election? None of your business. Bugger off. Non-responder, right? Not going to tell you. Volunteer response. What, isn't that the one where the guy in the radio says, if you believe in abortion, type this number. If you're against abortion, type that. Or if you turn up online and this little box appears, President Biden's going to give us all $10,000. Will you vote for him? Whatever. People, you know, that would be volunteering your response. Non-participation. Non-participation is you don't even take part. It's very close to non-response. Non-response, you get to ask them, and then they say it's none of your business. In non-participation, don't you send out the, you know, the letter which they're to fill in, and they just don't bother filling it in, right? Very similar. And let's look at some other ways in which collecting your data can go astray. Bias. Now, deliberate bias in questions. If you ask a question a particular way, you can change the response that you get. Yes, I'm in favor, or I'm against, right? If I went and said to you, are you in favor of a woman's right to choose, because that's an abortion question, I'll get a certain percentage who are saying yes and another percentage who say no. If I say to you, are you in favor of killing an unborn child? Can you see that the way I phrase that question will also affect the response? The way in which you deliberately ask the question can certainly affect the answer. The classic one is everybody wants free stuff as long as somebody else pays for it. That's a human nature thing, right? Which brings me to, the government has been really nice in giving me my money. You know, all those checks that we've been getting? And the government's been giving us free money, haven't they? Do you know the government hasn't given me any free money? Because see, all that money that they've given me doesn't have to get paid back. So all they're doing is giving me my own money back. The government doesn't make anything. The government only taxes people. Right? Have you ever heard of a government making something? In fact, it would scare me. See if the government ever made something, wouldn't the company go bankrupt? If you put the government in charge of
You mean like the post office?
like the post office, why not? Yeah. If you put the government in charge of the Sahara Desert, within a year, they'd run out of sand. That's how bad they are at running things. So government shouldn't run things. Most of the time they don't. But if you imagine then, where does this money come from? Your grandchildren are going to have to pay for it, or somebody's going to have to pay for it. There, I got that bit out of my system. I feel much better. Now, you can have intended bias, right? You deliberately phrase a question in such a way to get the answer you want. And that's very common in political questions. Can you imagine why the same different political parties said that they asked the same question, but they get totally different answers back? 40% of the population is in favor of this. And then the other one says 90% of the population are in favor of this. And couldn't that easily be because of the way you phrased the question? Now, unintentional bias is when you didn't really mean to cause any kind of problem, but the words that you use have to be prisoners. You have to make sure that you lock them down and that they have no, they're typically in English called power words. Give you an example. Murder, execute, kill. Those three words, somebody ends up dying. But for those three words, don't they have different connotations to how okay it is? Would you agree that execution sounds different from murder? Right. So if someone says, are you in favor of, Washington State executing murderers? Wouldn't you get a different answer if you said, are you in favor of Washington State killing murderers? You see, just that one word can make a difference. Now, you may not even know that you're doing that because, what a word means to you may not have connotations attached to it that you're aware of. But if English is not that person's second language, couldn't that become even more important? Because what you think the word means and what they think that word means may not always match the same way. This one's a cool one. People answer questions, and we all, mostly all of us, like to be nice and to be liked. So very often you will find that they will answer the question so that they are not put in a bad light. So if you ask people, do you mostly recycle all your stuff, right? Do you always put your stuff in the recycle bin? When you ask people that, would it surprise you to know that more people say they do than we know really do it? Because when we check the garbage, we notice that they're not always all recycled, right? Or vice versa. Now, why does that happen? Well, don't people not like people to think, oh, so you don't always do your vegan, you're a bad person. So they don't want people to think that, right? And you can also get it indirectly in other ways. Suppose you were asking people, oh, let's pick something. Yeah, I'll pick one. So do you think America is racially biased against Scotsmen? Now, most of you are probably not going to go too worried about that. But suppose it was a Scots person who was asking you that question. Can you see that the person who's asking you, even although it's the same question, could that influence you? So not just the phrase, the words you use, can't the person asking the question also? Can you imagine I had a question like, do you think they should increase the social security benefits? Right. And it was a 70-year-old, little old, frail-looking granny who was asking you that question. Or it was a 21-year-old, young guy asking that question. Can you see how you might be influenced by that as well? The subtle ones are the ones that catch you. Oh, this one I don't like, but I'm putting it in anyway. Asking the uninformed. Don't ask questions to people who probably don't know the answer. So if you went and said to people things like, I don't know, pick something. Do you think it was right for the French to withdraw their ambassador from America last week? If you don't even know that the French withdrew the ambassador, and you don't even know the reason why the French fella said that they were withdrawing their ambassador, won't there be a very good chance that whatever answer you give is not a very good one? Because you're uninformed about that particular piece of information. Does anybody here know that that's actually true? No? So I shouldn't ask you then, should we? Does anybody know why, allegedly, the French did that? they didn't like a nuclear submarine deal that was given to the Australians because the French thought they were going to get that deal, and now they're kind of miffed, roughly. That's the reason. Now that you know that question would have been fair, right, to those people who knew that in the first place. Next one is called unnecessary complexity. Don't make your question so long and convoluted that people don't even know what they're saying yes to. So here's an example. Shouldn't former drug dealers not be allowed to work in hospitals after they are released from prison? Isn't there a couple of double negatives floating about there? So I'm not sure if I say yes, what I'm saying yes to, or if I say no, what I'm saying no to. Do you see, the question is so badly worded, you're not sure what you're answering. Does that make sense? Should you say yes to that? I mean, it's your opinion, right? Or should you say no? Yes, they shouldn't be allowed to work, or no, they shouldn't be allowed to work. You see, it's hard to figure out what the meaning is to your answer. Here's a sneaky one that politicians use a lot. They don't ask you one question, they ask you two or three. And the first two questions, or one question, is to set you up for the last question, which is the one they're trying to influence you on. So question one would be, do you think that the national debt is too large? Question two would be, do you think we should increase the national debt by 4 trillion more? Do you see, by the time you've answered question one, won't that influence your opinion of what you might say in question two? So you preamble it with a couple of questions, one or two, that are to try and set you up so you won't contradict yourself when you hit three. Sneaky? Sneaky. We've talked about this one, confidential. Oh, I got a chat, I should look. Okay, I got you. Last one, perfect timing, because after this we're finished. Confidentiality, anonymous concerns. People don't answer sensitive questions very easily, because, you know, if I went and said to all of you here, how many of you have cheated on your partner? I think getting the truth would be quite hard. Agreed? Most people do not like to admit to negative things. Now, I'm sure that none of you have, but whatever, right? So, got to be careful when you do confidential questions. And one of the ways you can do that is to try and make it anonymous so that the person who's answering, nobody knows it was them. And if you can restrict it to the point where they don't even know they're being asked, or the information they're being asked will get out there. Example, suppose you want to find out drug use on high school students. You can't just go to the class and say, okay, put your hands up, how many of you have taken crack cocaine? Would you agree you're probably not going to get a lot of honest answers, if any? So how do you get around that? Well, each student would be taken and put in an office somewhere, and they'd get the questionnaire about what drugs they have or haven't taken in the last month. But before they do that, you tell them, look, your name's not in this. You're going to put X's, tell the truth, please, because we need this information, because it's going to help us in, for first responders to be aware of what the most likely overdose someone's got, right? If the drug of today is XYZ, right? If that's what a lot of high school students are doing, if there's an overdose going on, won't the first guy, well, okay, the chances are it's overdosed on XYZ, and they might know what to do about it, right? So you're giving them a reason for why you want to know it, right? And you tell them when you're finished, fold it up in a piece of paper, and there's a big box there, stick it inside there, give it a good shake. I don't know which one you put in. You don't know the other answers. You're gone. You see, if you do it that way, are you more likely to get an honest answer out of your high school kids? anonymous, no way tracing back to me. Here's a good reason for why I want to know it. Please tell me the truth. Right? Well, some lie, of course. Going to insult high school students here. They lie as a practice to get good at it. They'll lie about stupid things like, how many eggs did you eat? Oh, I only ate one. I gave you 2. Well, someone else must have ate the other one, right? There wasn't any reason to lie about how many eggs they take. Don't they just lie because it's good practice and want to get good at it, I guess. Okay, we are finished for today, and I am so pleased I nailed it on time.